We all know that digital computers changed virtually every aspect of our life.
Imagine a computer so powerful that it makes traditional supercomputers look like calculators. Google's latest quantum chip, Willow, has done just that.
Now, the latest development from Google.
Willow.
Google's Willow chip is touted as not just another technology breakthrough, but an evolution in the way we solve some of the world's toughest challenges.
Solving a problem in under 5 minutes that would take classical computers longer than the age of the universe. But the real shocker, some scientists believe this achievement might be proof that parallel universes exist. Could Google's quantum breakthrough be tapping into the multiverse? An idea once theorized by Stephen Hawking? Or is there a more down-to-earth explanation? Let's dive into the science, the speculation, and what it all means for our understanding of reality. Google's quantum computer just broke physics. Are we living in a simulation? But before we even get into whether quantum computers are tapping into parallel universes,
in a 5 to 10 year time frame, quantum computing will break encryption as we know it today.
we need to understand what makes them so different from the computers we use every day. Because without that, Willow's mind-blowing achievement won't really make sense. At their core, classical computers, like the one you're using right now, process information in binary, ones and zeros. Every operation, every calculation, every image on your screen is built from these two numbers switching on and off in predictable patterns. It's powerful, but also extremely limited when it comes to solving certain types of problems. That's where quantum computing changes the game completely. Quantum computers use qubits instead of traditional bits, and this is where things start to get weird. Thanks to quantum mechanics, qubits can exist in multiple states at once, a phenomenon known as superposition. This means they aren't just locked into being a 0 or a 1, they can be both at the same time. On top of that, they can be entangled, meaning that when one qubit changes, the others connected to it instantly change as well, no matter how far apart they are. Together, these two properties allow quantum computers to process information in a way that classical computers simply can't. Now, Google's new quantum chip, Willow, takes these principles and pushes them to a level that has left even experts stunned. With 105 qubits, it's not just an incremental improvement, it's a leap. To put it into perspective, every additional qubit doubles the processing power of a quantum computer, meaning Willow is exponentially stronger than its predecessors. But what really got people talking is what it did with that power. Willow was tasked with solving an incredibly complex problem known as a random distribution benchmark. A normal computer wouldn't just struggle with this, it would take 10 septillion years to finish, which is longer than the universe has even existed. But Willow, it cracked it in under 5 minutes. This level of speed is so absurd that it's forcing scientists to ask, how is this even possible? One of the more mind-bending theories that Willow's calculations didn't just happen within our universe, but across multiple parallel universes at once. This idea ties directly into the multiverse hypothesis, a theory that suggests infinite realities exist alongside our own. Some physicists believe that quantum computers might be the first machines capable of interacting with these alternate worlds. Google's quantum computer just shocked the entire world, but just how much faster is Willow compared to traditional computers? Sure, we know it solved a problem in minutes that would take classical machines longer than the age of the universe, but let's put that into perspective, because the scale of this breakthrough is almost incomprehensible. The concept of quantum supremacy refers to the moment when a quantum computer outperforms even the most powerful classical supercomputers at a specific task. In 2019, Google claimed to have achieved this with its 53-qubit Sycamore chip, solving a problem in 200 seconds that would have taken classical computers about 10,000 years. But that was just the beginning. Willow's 105 qubits don't just double the computing power, they push it exponentially forward. To understand just how big this leap is, imagine a standard computer solving a maze by testing one path at a time. It works through possibilities in sequence. A quantum computer, on the other hand, can explore every possible path simultaneously because of superposition and entanglement. This allows it to arrive at the correct solution almost instantly. The problem Willow solved, a random distribution benchmark, wasn't just difficult, it was functionally impossible for classical computers. Even the most advanced supercomputers like Frontier, which runs at 1.1 exaflops, a quintillion calculations per second, wouldn't stand a chance. The fact that Willow completed the task in 5 minutes is a mind-bending demonstration of just how powerful quantum computing has become. But this is where things get weird. Some physicists argue that quantum computers don't just solve problems faster, they might be operating in ways that defy our conventional understanding of physics. Hartmut Neven, the head of Google's quantum AI lab, once hinted at something truly wild, that quantum computers might be tapping into parallel realities to perform calculations. It sounds like science fiction, but there's a reason why this idea is gaining traction. Traditional computing is bound by linear processing, each operation follows the last. But if quantum computers truly leverage entanglement and superposition, they could, in theory, distribute computations across multiple realities, with each reality solving part of the problem. Then, when the quantum wave function collapses, we get the final answer in our universe. Of course, not everyone buys into this interpretation. Critics argue that quantum supremacy doesn't require invoking the multiverse, it's just a result of the fundamental laws of quantum mechanics. Essentially, they say quantum computers are simply taking advantage of probability waves, not borrowing computing power from alternate dimensions. But regardless of the explanation, what's undeniable is this: Willow has crushed any previous performance records in quantum computing, and it did so with a level of efficiency that has left researchers stunned. More importantly, it's the biggest step yet toward making quantum computing practical for real-world applications. So, the real question now isn't just whether Willow achieved quantum supremacy, it's what happens next. Because if this is what a 105-qubit quantum computer can do, imagine what happens when we reach 500 qubits, or 1,000, or 1,000,000. Are we living in a multiverse? Quantum physics might have the answer. But here's the real question: how is any of this even possible? How can a quantum computer like Google's Willow achieve speeds that seem to defy logic? Some physicists believe the answer might be bigger than we ever imagined, literally. It could be hidden in the very nature of reality itself, in a concept known as the multiverse hypothesis. The idea that we might not be living in a single, isolated universe, but rather one of infinite parallel universes has been around for decades. It started as a purely theoretical concept, but quantum mechanics, the branch of physics that governs the subatomic world, has given it serious weight. One of the biggest mysteries in quantum physics is something called wave function collapse. When a quantum particle, like an electron, exists in a state of superposition, it's essentially in all possible states at once, but the moment we observe it, it chooses one reality. Scientists have spent years trying to figure out why this happens. Enter the many worlds interpretation, MWI. In 1957, physicist Hugh Everett III proposed something radical. What if the wave function doesn't collapse at all? What if, instead of a particle choosing one state, reality itself splits into multiple versions where each possible outcome actually happens? That means every time a decision is made, every time a quantum event occurs, an entirely new universe is created to accommodate each possibility. Take something as simple as flipping a coin. In our reality, it lands on heads, but in another just as real, it lands on tails. These two universes branch off from each other, and neither is aware of the other. The same principle could apply on an enormous scale, creating an infinite number of parallel universes. Now, this is where things get really interesting. If quantum computers like Willow are leveraging superposition and entanglement to perform calculations, then some physicists believe they might actually be using these parallel universes to compute different parts of a problem simultaneously. In essence, the multiverse isn't just some sci-fi concept, it could be a real physical resource for computation. David Deutsch, one of the pioneers of quantum computing, has strongly supported this idea. He argues that quantum computers prove the existence of the multiverse because they perform calculations that would otherwise be impossible in a single universe. According to Deutsch, each calculation is being processed across many worlds, and the final answer only appears when these computations merge back into our own reality. Of course, not everyone is on board with this interpretation. The Copenhagen interpretation, The most widely accepted view of quantum mechanics states that quantum superpositions are just probabilities, and when we measure them, the wave function collapses into a single state. In other words, no need for parallel universes, just pure randomness at work. But here's where things get tricky. The Copenhagen interpretation has never been able to fully explain why or how the wave function collapses. It simply states that it does. Meanwhile, the many worlds interpretation offers a clean and logical explanation. The wave function doesn't collapse, we just experience one of the many possible outcomes. So, does this mean quantum computers are direct proof of the multiverse? Yes, potentially. It surely might be the strongest experimental hint we've ever had. If quantum computers truly are tapping into parallel realities to speed up their calculations, then we may already be witnessing the first tangible evidence of the multiverse in action. And if that's the case, then the implications are staggering, not just for computing, but for our entire understanding of reality. But here's where things get even stranger. We know that quantum computers like Willow operate fundamentally differently from classical machines. But what if their speed isn't just a result of better engineering? Some physicists are starting to wonder whether Willow's unprecedented performance is hinting at something far bigger than just a technological leap. What if it's revealing something about the nature of reality itself? Willow's mind-blowing performance is already shaking up the scientific world, but the real debate isn't just about speed, it's about what it might mean for our understanding of reality itself. Some physicists believe that what happened inside Google's latest quantum processor could be more than just advanced computation. It could be the first real evidence that parallel universes exist. The reasoning behind this claim comes from the many worlds interpretation of quantum mechanics. In short, it suggests that every possible outcome of a quantum event actually happens, but in different separate realities. The idea has always been largely theoretical, but Willow's sheer computational speed has some scientists wondering if we might finally have experimental proof. How Willow's speed connects to the multiverse. Google's 105-qubit quantum chip Willow solved a problem that classical computers would take over 10 septillion years to compute. This is an almost meaningless number. It's so large that it's beyond human comprehension. But what makes this even stranger is that, according to some interpretations of quantum mechanics, no single universe should have enough computational power to process this kind of information so quickly. Hartmut Neven, a leading figure at Google's quantum AI lab, has suggested that Willow's results could align with the many worlds interpretation. The argument: if quantum systems explore multiple possibilities at once, and if each possibility happens in a different universe, then maybe Willow's insane speed is because it is literally splitting its computations across multiple parallel realities, with each reality handling part of the problem before combining the results into our own. This would mean that when Willow performed its 5-minute calculation, it wasn't just working in our universe, it was borrowing computational power from other universes to solve the problem faster than should be possible. Quantum computer might finally prove Hawking's multiverse theory. If quantum computers like Willow really are hinting at the existence of parallel universes, then one of the most important questions to ask is, was this something that Stephen Hawking predicted? After all, Hawking spent much of his life unraveling the mysteries of the cosmos, pushing the boundaries of what we know about black holes, time, and even the possibility of multiple universes. Could his work be the missing link between quantum computing and the multiverse? Hawking wasn't just a theoretical physicist, he was a visionary who reshaped our understanding of reality. One of his most fascinating contributions came in his later years when he explored the concept of a finite but vast multiverse. Traditional multiverse theories suggest that an infinite number of universes exist, all branching out from different quantum events. But Hawking, along with physicist Thomas Hertog, proposed something slightly different: the idea that the multiverse is not infinite, but rather has a structured, limited number of possible universes. This idea stems from Hawking's work on black holes and quantum mechanics. He famously discovered that black holes aren't entirely inescapable. Thanks to what we now call Hawking radiation, black holes slowly lose energy over time and can eventually evaporate. This was groundbreaking because it linked gravity, quantum mechanics, and thermodynamics, three of the most important yet seemingly incompatible areas of physics. Later, Hawking turned his attention to the early universe. He argued that due to quantum fluctuations at the birth of the cosmos, our universe could be just one of many that emerged from the Big Bang. However, unlike traditional many worlds theories, Hawking and Hertog suggested that these universes aren't entirely random. Instead, the laws of physics might impose constraints, leading to a multiverse that is mathematically structured rather than infinite chaos. So, how does this connect to Google's Willow quantum processor? If quantum computers are performing calculations that seem impossible within a single universe, and if these calculations align with theories that suggest quantum systems operate across multiple realities, then Hawking's vision of a structured multiverse might be closer to the truth than we ever imagined. Of course, Hawking never explicitly claimed that quantum computers would prove the existence of the multiverse, but his work laid the groundwork for understanding how quantum mechanics could extend beyond our reality. If Willow's performance hints at computation happening across multiple universes, it could be one of the first practical demonstrations of multiverse physics, supporting ideas Hawking and others had been exploring for decades. Quantum computers might unlock the secrets of the universe. If Hawking's theories are even partially correct, then Willow's mind-blowing performance could be the first step toward proving ideas that have remained purely theoretical for decades. But that's just the beginning. The real impact of this quantum revolution won't just be about parallel universes, it's about transforming everything we know about science, technology, and reality itself. Quantum computing is advancing faster than anyone predicted, and its implications stretch far beyond solving abstract problems. Scientists believe that chips like Willow could be used to test and prove some of the most controversial and mysterious theories in physics. Concepts that have remained untested due to technological limits may finally be within reach. For example, one of the biggest unanswered questions in physics is the unification of quantum mechanics and general relativity. Right now, we have two sets of rules, one for the microscopic quantum world and one for the macroscopic world of gravity and relativity. The problem? These two theories don't play well together. Quantum computers might help simulate extreme conditions, like the inside of black holes, or the moments after the Big Bang, giving scientists clues about how the universe really works on the deepest level. Then there's the holographic principle, a mind-bending theory that suggests the entire universe might actually be a hologram, with everything we experience being encoded on a distant boundary. This theory has remained mostly speculative, but quantum computers could help simulate the mathematics behind it, testing whether space and time themselves emerge from deeper quantum interactions. Another breakthrough possibility? Quantum gravity and the nature of space-time. Some physicists, including those working on loop quantum gravity and string theory, believe that space-time itself is made up of tiny discrete units. Right now, this is impossible to prove with conventional methods, but quantum computers might be able to model these structures and test whether space and time are continuous or fundamentally pixelated at the smallest scales. Outside of physics, the impact of quantum computing is just as staggering. The ability to perform calculations at an unimaginable speed could transform fields like drug discovery, materials science, and cryptography. Imagine being able to simulate molecular interactions with perfect accuracy, leading to cures for diseases that were once thought untreatable, or developing materials that are lighter, stronger, and more efficient than anything we've ever seen. And then there's the elephant in the room, artificial intelligence. If quantum computing merges with AI, the results could be beyond anything we can currently predict. Machine learning models that take years to train could be optimized instantly. AI could make breakthroughs in physics on its own, discovering patterns in data that humans could never recognize. But with great power comes great responsibility. If quantum computing advances too quickly without ethical considerations, it could also pose serious risks. The most obvious, breaking encryption. Most modern security relies on mathematical problems that classical computers can't solve in a reasonable time frame. But quantum computers could shatter existing cryptographic systems, making current cybersecurity useless overnight. One thing is clear, we are on the edge of something massive. Whether it's proving the existence of parallel universes, rewriting our understanding of reality, or revolutionizing every major industry, the quantum computing revolution isn't coming. It's already here. And what happens next, that's something even science can't fully predict yet. Is Google's quantum computer really proving the multiverse? Not everyone's convinced. Is Google's quantum computer really proving the multiverse? Not everyone's convinced. Of course, not everyone is ready to declare that quantum computers have unlocked parallel universes. For every jaw-dropping claim about Willow's capabilities, there are just as many skeptics arguing that the multiverse explanation is nothing more than wild speculation. Could there be a far simpler reason why Willow performs so well? One of the biggest criticisms comes from physicists who argue that the many worlds interpretation isn't necessary to explain quantum computing's success. The argument here is simple. Just because quantum computers operate in a way that seems strange to classical physics doesn't mean they require alternate realities to function. Instead, skeptics suggest that Willow's performance is purely a result of quantum mechanics, as we already understand it. No extra universe is needed. Another key counterpoint: error correction and optimization. While it's true that Willow completed a problem in minutes that would take classical supercomputers billions of years, that doesn't necessarily mean it was doing anything outside of our reality. Some researchers argue that Google's advancements in quantum error correction could be the real reason behind its incredible efficiency. Simply put, better technology, not parallel worlds, could explain its success. Then there's the issue of what Willow actually did. The problem it solved, our random distribution benchmark, is impressive but not a real-world application. Critics argue that while quantum supremacy sounds exciting, it doesn't necessarily translate to practical breakthroughs just yet. In other words, Willow's feat was more of a proof of concept rather than something with immediate scientific or technological impact. Skeptics also point out that past quantum supremacy claims have faced pushback. When Google first announced that its 2019 Sycamore chip had achieved quantum supremacy, IBM quickly responded, claiming that a well-optimized classical computer could have done the same calculation in days, not thousands of years as Google initially suggested. This raises the question, could a similar counter-argument emerge for Willow's latest milestone? And finally, there's the most fundamental question: if quantum computers were really tapping into parallel universes, shouldn't we be able to test that in a more direct way? Right now, there's no experiment that definitively proves the existence of alternate realities. The multiverse remains an exciting but theoretical concept, with no concrete way to verify if quantum computers are using it to compute.